Number sequence. A number sequence is a succession of numbers in a specific order. In the sequence 3, 6, 9, 12, 3 is the first number, followed by 6, followed by 9, and followed by 12. Each number in the sequence is called a term. So 3 is a term of a sequence, 6 is also a term, 9 also is a term, and 12 is a term. And all the succeeding numbers of this sequence are called terms. They are arranged as the first term, the second term, and the third term, and so on. In this case, we can say that 3 is the first term, 6 is the second term, 9 is the third term, 12 is the fourth term, and so on. The terms are formed according to some fixed rules of or property. Let's again consider 3, 6, 9, 12. We can say, by observation, we can see that if we add 3 to 3, we get 6, and we add 3 to 6, we get 9, and if we add 3 to 9, we get 12. So, the fixed rules and property of this term is that we add 3 to the previous term to get the next term. So, this is just one of the many properties of a terms. It is also a function defined on a set of positive integers. Let's consider again 3, 6, 9, and 12. We can say that this is a function f of n is equal to 3n, wherein the value of n should be a positive integers. 0 is not included because 0 is not positive. -1, -2, and other negative numbers is not also included because this is not a positive integer. Square root of 1, square root of -1 is not an integer, so this can't be a value of n. Now let's try to see if this is a function for this set of number sequence. So let's consider n have values of 1, 2, 3, and 4. The value of n are all positive integers. Now let's try to substitute the value of n into 3n. So we have 3 multiplied by 1, 3 multiplied by 2, then 3 multiplied by 3, and 3 multiplied by 4. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. Therefore, we get a sequence 3, 6, 9, 12. So therefore, this is a function of this sequence. A sequence with a definite number of terms is a finite sequence, meaning we can count the number of terms in this sequence. It has an n. For the sequence 3, 6, 9, and 12, this sequence has 4 terms. Therefore, it is a finite sequence. The following sequences are finite. Sequence 1, 2, 3, 4, 5 has a first term of 1 and a last term of 5. And if we count the number of terms, we have 1, 2, 3, 4, 5. We have 5 numbers of terms. If we're going to compute all the terms in between 4 and -20, 48, we can say that we have 12 terms in this sequence. And we can see that -2 is the first term and 4096 is the last term. Again, a finite sequence has a first term and a last term. Considering the sequence 38, 33, 28, 23, 18, 13, We can say that the first term is 38 and the last term is 13. Because it has a first and a last term, we can consider this as a finite sequence. Now, if we're going to count the number of terms, we can say that 1, 2, 3, 4, 5, 6. We have 6 terms in this sequence. The first and the last terms of a sequence are referred to as extremes. Going back to our example, the first term and the last term is what we call extremes. So in this case, 1 and 5 are the extremes of this sequence, 1, 2, 3, 4, 5, and negative 2 and 4096 are the extremes of the second sequence, and 38 and 13 are the extremes of the third sequence. The terms between the first and the last terms, or the between the extremes, are called means. We know that 1 and 5 are the extremes, therefore 2, 3, and 4 are the means. In this case, these are the extremes, negative 2 and 4096. All the numbers between them in this sequence are the means. The extremes are 38 and 13. Then all the numbers between them are the means. So that's for the finite sequence. Infinite sequence. A sequence with no definite number of terms are infinite sequence, meaning we cannot count the number of the terms in this sequence. Let's consider the following sequences: negative 9, negative 2, 5, 12, 19, and so on. We can say that this sequence has a first term of negative 9, but we cannot determine its last term. So how can I say that it has no last term? Why is it 19 isn't the last term? Because of this symbol. The ellipsis tells us that the sequence continues and it doesn't have a last term. Now, let's see for the next example. 27, 9, 3, 1, 1/3, 1 over 9, and an ellipsis. This ellipsis, and after the ellipsis, we cannot see any number. So therefore, our first term is 27, and we cannot say what is the last term because it has no last term. On the last example, we can see the ellipsis at the beginning of the term, and we have negative 16 as the last term, but we cannot determine the first term. It is also an infinite sequence because the number before 64 continues through infinity. So we have no first term for this kind of terms. So these are the examples of infinite sequence. Now let's try to answer some examples. Write F if the sequence is finite, or I if the sequence is infinite. On number 1, we can say that the first term is 3, and we can say that 11 is the last term. But these ellipses at the middle state that there are terms between 6 and 11. But still, we have 11 as the last term. So this is a finite sequence. On example number 2, we can see that 24 is the last term, but there's no number before the ellipses. So we can say that the terms before 6 are infinite. So this is our infinite sequence. Number 3, we can see that 6 is the first term, and we can see a last term for this sequence. So therefore, this is an infinite sequence. Number 4, we have 4 as the first term and 108 as the last term. So we have first and last term. So therefore, this is a finite sequence. On number 5, the first term is 1/4, and we can see a last term after the ellipses. So therefore, this is an infinite sequence. So that is the way to identify whether a sequence is a finite or an infinite sequence. Now let's go to example number 2. Find the next two terms of each sequence. So all we have to do is to know the rules and find the next two sequence. So we have the following given. Let's start first with letter A. A is 4, 7, 10, and 13. So if by observation, if we start with 4, how can we get 7? What are we going to do to get 7? So we know that we could, if we add 3 to 4, we get 7. Now let's check if that's also the case for the next term. What are we going to do to 7 to make it 10? So the answer is also by adding 3. Now, next term is how do we get 13? What are we going to do to 10 to get 13? We can also add 3 to it to get 13. Now, the next two terms will be the we're going to find. Now, if the pattern is by adding 3, therefore, if we add 3 to 13, what will be our next term? And that is 16. Now, 16, if we continue the pattern plus 3, 16 plus 3 will be 19. So, therefore, the next two terms are 16 and 19. So that is the next two terms. Now let's try letter B. Find the next two terms of each sequence. Again, let's start with the first term, 15. What are we going to do to 15 to get 7? Now the answer is we subtract 8. Now what we're going to do to 7 to make it negative 1? Also, we subtract 8 because 7 minus 8 is equal to negative 1. So what are we going to do to negative 1 to make it negative 9? Again, we subtract 8. So we can get negative 1 minus negative 9 because it has the same sign. We just copy the sign. I'm sorry, this is 8. We just copy the sign and add the numbers after the sign. So that is 9. Now, here's the problem. We know the pattern now. You subtract 8. What will be the value if we of the next term? So we have 9, negative 9 minus 8. That will be negative 17. Now, negative 17 minus 8, if we continue the pattern, we will get negative 25. So, the next two terms are negative 17 and negative 25. So this will be our answer. Next example, we have 7, 14, 28, and 56. Now what are we going to do to 7 to make it 14? All we have to do is to add 7. Now what are we going to do to make to 14 to make it 28? Are we going to add 7 as well? Would that be equal to 28? 14 plus 7 is 21. It's not 28. So therefore, adding 7 is not the, the property or the pattern that we are looking for. Now let's try another way. What are we going to do to 7 to make it 14? So yeah, we can multiply it by 2. So 7 times 2 is 14. Now 14 times 2 is 28. Then 28 times 2 is 56. Now we have a common pattern by multiplying 2. Now we need to compute for 56 multiplied by 2. So that is 112. Now 112 multiplied by 2 is, that is 4, that is 224. Therefore, the next two terms are 112 and 224. So these are the next two terms. Now let's go to our final. These are basic example of terms only. Now let's go to the under the second example, letter D. Now what are we going to do to 24 to make it negative 12? If we know, we should divide it by negative 2. Because 24 divided by negative 2 is equal to negative 12. Now let's try to divide it to negative 2 as well. So negative 12 divided by negative 2. So they are both negative, so the answer will be positive 6. Now 6 divided by negative 2 is negative, divide negative 2 is negative 3. Now we have the common pattern of dividing by negative 2. Now let's try to solve for this. Divided by negative 2. So negative 3 divided by negative 2. So both negative, so we have positive 3 over 2. That is 3 over 2. Now let's try to divide this again. Divided by negative 2. So we have 3 over 2 divided by negative 2. So this is a complex fraction. All we need to do to, to solve for a complex fraction is to get the reciprocal of the denominator and multiply it to the fraction numerator. So we have 3 over 2. What is the reciprocal of negative 2? The reciprocal of negative 2 is negative 1 over 2. Negative 1 half. So 3 times 2, 3 times negative 1 is negative 3, and 2 times 2 is 4. So we have negative 3 over 4. So the answer for this, the next two terms are 3 over 2 and negative 3 over 4. So these are the answer. So that's how to find the patterns and look at for the next number. Now let's go to a practice part of the lesson, wherein we're going to solve difficult or average problem. Now the question is, find the next term of each sequence. So we have 5 sequences. So we just need to find the next term. Now let's consider this. 3, 9, 81. How can we get from 3 to 9? So all we have to do is to 3, we multiply it by 3, then we get 9. Now on this part, We cannot multiply 9 by 3 because if we multiply 9 by 3, we get 27 instead of 81. So what is the pattern for this? Now look at you see, if we square this, 3 squared, we get 9. And 9 squared, we get 81. Now next is, to get the next term, we need to 81 squared. Now in this case, we have to use calculator because 81 squared is somehow 81 squared. So we can say, so we know that the answer for this is 6,561. So we have 6,561. So that's how we get the pattern for this example. So the answer is 6561. This is a unusual pattern, but it happens. Let's go with letter B. This is also a unique kind of sequence wherein we get the succeeding term. This is what we call by combining the first three terms. So if we add 1 plus 1 plus 2, we get 4. And if we add 1 plus 2 plus 4, we get 7. And we add 2 plus 4 plus 7, that is 2 plus 4, 6, 6 plus 13. Now to get the next term, we just add these 3. So 4 plus 7 is 11 plus 13 is 24. Again, 24. Again, may I repeat. 1 plus 1 plus 2 is equal to 4. Next is 1 plus 2 plus 4 is equal to 7. Next, 2 plus 4 plus 7 is equal to 13. Now 4 plus 7 plus 13 is equal to 24. So that's how we get the next term of this sequence. Now how about this? 22, 21, 19, 16. At first, you can say that it's just we just subtract 1 to get the next term. But when you go here, the number changes. So let's try to do the pattern. So from 22 to make it 21, we minus 1. Now from 21 to make it 19, we minus 2. Now from 19 to make it 16, we minus 3. Now what are we going to do to get the next term? So you can see the pattern at the on this part. So from negative 1, from minus 1, it becomes minus 2, it becomes minus 3. Now all we have to do is to minus it 4. So 16 minus 4 is 12. So the next term, the answer is 12. So it seems easy, but it's great. Now, this one. This is also an interesting sequence. So if you try to do it, so we have minus 1, then plus 3, then minus 2, then plus 4, and we could see a pattern at the bottom. But if you will look closely, you can look at this 2, 4, 6, 8. Then 1, 2, 3, 4. So what is the next term here? So we will just follow this 2, 4, 6, 8. Then the next term is 10. And if we're going to push through, the next term is 5. Then 12. Then 6. But since we just need the next term, so we can just 2, 4, 6, 8, 10. So 10 is the next term. Last, this this term is called Fibonacci sequence. So to get the next term, we just need to focus on those first two numbers. So 2 plus 3 is 5, then 3 plus 5 is 8. Now 5 plus 8 is 13. Again, 2 plus 3 is 5, then 3 plus 5 is 8. Now to get the next term, we just add 5 and 8, and we get 13. So 13 is the next term.